And start, yeah, no, thanks for everyone hopping on. Happy New Year. I hope everyone had a good holiday and refreshed. So yeah, let's dive into it. I have this up every time in case people have um, insights or help to maybe try to figure out how to do an in-person meeting. We need sponsors. That's what we would need to do it in either U.S. or other countries. But it'd be kind of neat to have it, and I guess as Paco alluded to earlier, everyone's tired of COVID even meeting, so not having a COVID focused meeting, but having something around it, like long COVID and other issues and other subjects might be more appealing for people. So, but we could talk about that later. Just the papers, there's people from last year. There's a bunch of papers that we all put out. The two latest papers were from our group was this iScience paper that Rob Miller had led, and then also this paper that came out in the beginning of December, which is from the microbial group. And I should ask Krista to see if she wants to present this to one of our Friday meetings. But it's a really neat paper. But if you haven't checked it out, but looking at metatranscriptomic data and looking at the association of different microbes, with COVID infection. So they did a really nice job there. Yeah, and just updates that I've posted. These haven't changed much from before the holidays. I know Al was going to try to do a monkeypox group. Monkeypox is still around, but it's kind of not as prevalent as, it hasn't taken off. It's just kind of stable, I should say, but it's still around. But then also before the holidays, Al got busy and couldn't do it, but I'm sure he would want to pick this up again. There's two case reports that we talked about with long COVID that he wants to tackle. People want to help him with that. And then, as I keep promising before the holidays, but now I really promise, I'm going to try to start up a long COVID subgroup to push it through. There's some studies that we would want to do, especially like the COVID twin study that we started pushing forward. We have to circle back with that. And then, of course, record these, make these public, these updates I make. All right, so let's dive into the news. So in the U.S., before the holidays, I had mentioned that there's free COVID tests were offered again. You can go here, click on here, covid.gov/test, and they still offer the free test. So if you happen to be in the U.S. and didn't take advantage of this and want some free tests, they mail you 4 free tests. I got mine. Do that. Sorry for European folks. You have to consult your government for doing this, giving you free tests, unfortunately. But let's dive into what's happening. There's this one article that came out yesterday, yeah, January 3rd. But talking about there was this study, well, it wasn't really a published study, but it was released by the National Public Health Laboratory in Malaysia, where they looked at basically positivity in the wastewater from the airplanes. And they looked at, they looked at 29 flights over from June to December last year, and looked at these samples, and they basically said, there's a 95.7% positivity rate of SARS-CoV-2 detected in all these flights, which is maybe not so surprising, but which indicates more and more that with cases going up again and everything going up, the whole point is you should probably wear a mask on a plane, where previously people were saying it might not be necessary. But that's what this came out. I mean, again, this is released by the Public Health Laboratory in Malaysia. So, and then, there's some other news articles talking about, well, with the cases skyrocketing in China and everything happening, people are considering, like in the U.S., maybe potentially doing a wastewater surveillance. I don't know if anyone here who's a wastewater like Adam, a wastewater person like Adam, if they've heard about this or have any insight if they're going to start doing surveillance on planes for wastewater.
We're actually working on a project right now that's doing that. It's pretty interesting stuff, actually. So, I guess the idea is if you're able to look at international flights and, focus the efforts on that, you might have a better understanding of what's coming in internationally. Yeah. But it's really some interesting stuff because it's a different matrix than traditional wastewater. That blue water is more concentrated. There are some chemical additives that you need to account for. It's not quite as straightforward, but there's some really interesting data coming out of it.
That's interesting. Yeah, I guess further along, if you guys actually have data you want to share one of these groups, I'd be more than happy to see if you want to present later.
Oh, absolutely.
Later.
When the time comes that we're able to do
Yeah.
that, I'll let you know.
Yeah, yeah, sounds good. Yeah. Yeah, it'll be fascinating to hear what the results are. And even if I bet you're just not looking at COVID, you're probably looking at other types of viruses too, right?
I'm not sure what I can say actually, to be
Oh, okay,
completely
okay.
honest.
No, no, perfectly fine. All right, we'll wait eagerly for your updates
All right, sounds good.
once you're able to share.
Yeah, yeah.
Thanks, Adam. Okay, so that's interesting that they're still doing that. Might be worthwhile. And then, of course, what's happened in the past couple of weeks, which are very well U.S. homegrown virus variants, I should say, popped up, is this XBB .1.5. And Eric Toppel's blog, I really like, as I've always said in the past. He does a really good job of summarizing. I think he put this out right before the holidays on December 23rd. But of course, it's been in the past 2 weeks, things changed drastically to the worse. But he does a good summarizing it. So if you remember, XBB first popped up in Singapore back in October, which was here. There's a little peak, as you see here. And then I put the map for Europe, United States, and South America here. I should put Asia here too. But just to show what the case is happening. But you can see, like in Singapore, the cases went down. They didn't have that many deaths. But the reasoning behind that many deaths also is that, I'll go into later, is that you notice that Singapore is probably one of the highest vaccinated countries out there. They even surpassed Portugal. But their booster rates are even one of the highest compared to everywhere else. So that's what people are hypothesizing, saying potentially why there was low death rates and hospitalizations weren't really reported that well in other countries or in Singapore. But the lower death rates could be attributed to potentially getting the latest boosters and things like that, which I'll go into in a second. So I've been learning about what this new XBB.1.5 is. It's a recombinant, as you see from these, BJ.1 and BA2.75. Want to have a question, or we could keep going? If you have questions, our comments, just speak up. Oh, if not, we'll keep going. Okay. Okay, yeah, so it's a combination of that, and then this is a nice little diagram that Eric Tauber put that they got from a person here, from Ryan Histler, I think, or someone else. But you just read the blog, it tells you who these figures are from. But what's interesting is that there's this mutation here, F487P, which is clearly the main thing that people have been reporting is going to be causing, this red thing should be here on this F487S and P. And anyway, so this is the mutation that's actually causing it to potentially have the most immunity escape, which is being reported even since August when this variant started popping up. And so there's, from other folks in the field, whether it's Jesse Bloom or these guys, he's been talking about, this is the mutation that's going to probably be very worrisome because of the XBB.1.5 making it spread more quickly. And some of the reasons why people are reporting down here. If people have more insight, speak up. I'll keep going, or people could pop in with more insight. So in his blog, again, he kept on talking about the different mutations and talking about, so this might be informative, the key sites where potentially this variant might be evading or the current vaccines, or might be, have still neutralized an Omicron. And then just to bring it, I usually show this a little later and I'll show it again, but, interesting enough, since 2 weeks ago in the CDC tracker, now they've actually put accounting for XBB there. Might call mute. Okay, so then we could see that before the holiday break was BQ.1, and this is what this was here. But since the holiday break, the nowcast forecast is showing that the nowcast prediction, I should be saying, is showing that this is pretty stagnant now. It hasn't changed BQ.1.1. But what has changed is in the past 2 weeks, or pretty drastically, that last update was on Saturday. Is how you see XBB.1.5 quickly taking over in the U.S. and as has been reported, as you probably read, it's the New England area, Northeast area is dominantly spreading this everywhere else. As I think Paco pointed out, there's one case that happened to show up in Portugal, probably coming from the U.S. or New England or in Northeast. Just a speculation, but anyway, you can see how it's dominantly starting in this region of the U.S. and not as prominent yet in the rest of the U.S., but it's migrating, I would imagine, as people predict. Some papers regarding around this. This paper came out, when did it come out? In December 13th, talking about XBB, the original 1.1, and talking also BQ.1.1, how there's the properties that would make it the most immune evasive variant seen to date. So people can read this about the key mutations, where they're found. That one mutation I mentioned earlier, the F486P, they talked about in this paper. So then again, you can see how, for example, the neutralization by Sarah, you can see the XBB.1 is down here and does a very good job at that. One thing, again, New York and the Massachusetts is kind of the places that is really prominent. This is from the New York public health site. You can see that from the hospitalizations being reported, I know I heard, for example, our colleagues like Rob Schwartz, he's been inundated with swamped at the hospital with people coming in. You can see why. Here's the hospitalizations, coming in, the newly reported hospitalizations over time. You can see how much higher it is. This is the spread. This is the distribution of the variants in the New York area. And you can see that it's pretty dominant. XBB.1 here is that purple. XBB.1.5 is that purple, which is about 72, 73% of the cases. So that's concerning. And then when you look at the hospitalizations, of course, what we would expect is the older population. This is from the New York Times trackers. You can see 70 and plus is what's the population of ages we would expect being impacted the most. You can see this is New York, this is Massachusetts. So it's in the rest of this U.S. is, I think, going to be following this pretty closely in the next few weeks from what we see here. Because it spreads pretty quickly. And the point we're making about the boosters and the violence, what I'm showing in a couple of slides, is that in the U.S., people, I think it's about 30% of people who've gone on the latest bivalent booster, which compared to Singapore was, go back to that slide, which is about like 70%, or 60% is reported. So that's the concerning part too, but people haven't updated their booster shots. And this is where this comes into now. Leads in. There's this New England Journal of Medicine short little paper on December 21st that came out talking about neutralization against these variants. And it shows basically this paper, this is the only figure in the paper, but in the nutshell, they talked about that people who receive that newest bivalent booster, they overall have a better neutralizing activity against all the Omicron variants, including the XBB. They don't have much information about XBB.1.5 yet, but they're assuming it should, not in this article, but all the people talking about it subsequently assume that most likely this still will hold for XBB.1.5 from what I've been reading.
I may be missing stuff, but I don't usually see like plots of like the one that you showed before about like hospitalization rates in terms of age and booster, if they've had the boosters or not, and which boosters they've had.
Yeah, I haven't seen those plots either. That'd be useful. Someone made those. If you find one, though, you let me know. Yeah, that's the only thing that's tough. I don't think what we see is that we say 30% of people probably have gotten the booster in the U.S. and then they leave it at that. Yeah.
Option, Steve. Very quick question. In addition to the mutation, that specific one you described, in addition to the immune consequences or evasion, in terms, is it like a gain of function in any way for ACE2 binding that actually facilitates transmission, or it's neutral in that regard?
Yeah, so I have to read more about it, but it looks like it's doing something with the ACE2 binding string, this mutation, as they talk about here.
That's what struck me when you were...
Yeah, I mean, I don't know if Nydia's here. She's, I think, still in Portugal. Vacation. Yes, I usually go, but maybe someone else might have more insight because I've been reading about it, but I think there is something to it, what you're saying, Steve, but I just don't have enough information myself
Okay.
on it. But I have
Yeah,
to do more reading on it. Definitely, I think there's something happening there.
that'd be really interesting, to know
Yeah.
that.
Does
Thanks.
anyone else know over Steve's question? Yeah, no one else does. Yeah, I tend to go to my. Nadia is a very good person with that type of knowledge and that information usually. So, yeah, but definitely, there seems to be this paper here talks about it a little bit, but again, like the ACE2 affinity of these variants were similar to parental strains of they're talking about the BA variants. But I didn't read this paper in depth. I just kind of skimmed over it. So they talk about it here a little bit, Steve, in this paper, this cell paper.
Look back. Thank you.
Yeah, yeah. Yeah, so the bivalent boosters seem to be, people get it. I'm sure everyone here has. But this is just and then leading to, looking up, is there any new symptoms? Some articles saying, hey, is there any new symptoms happening with the XBB.1.5? And overall, they're saying, the symptoms are pretty persistent still, but, for example, previously runny nose things and being very, if you had the bivalent, what they're saying, it's more like a cold-like symptom as opposed to severe, but if you haven't had the bivalent booster, then you could lead to more severe fever or flu-like symptoms and more fatigue. But one thing that I've been reading too is that one of the more prominent symptoms with this variant seems to be muscle aches and myalgia. So that's, I guess, more so than, let's say, runny nose or other previous symptoms. But again, I guess we'd have to consult our clinicians. I know Rob's probably Rob Schwartz is probably swamped in the clinic, so we would have to ask him what he's been observing when he's in the clinic, deep in it. But from what I've said, yeah, go ahead. Sorry.
Yeah, this is Kevin. So you're describing acute infection symptoms. Is that
Right.
correct?
Yeah.
Yeah. So are you aware of any deviations from possible long-term COVID symptoms?
Yeah, I think no one's talked about it. It's too early.
How long has it been a prominent variant? Is it a month to 2 months, or is it much less than that? About weeks?
It's like 2 weeks. It really took over quick. I mean, it's been around, right? It's been around.
Yeah, that's what I thought. Yeah.
Yeah. So that's why it's too. I mean, it's been like in Singapore.
It's just that maybe there's not enough data yet
Right.
accumulated to make any determination.
Exactly. Yeah. I mean,
Okay, thanks.
yeah. So I guess we'll have to keep our eyes peeled. In Singapore, they haven't really reported much about the long COVID things either, and that was back in October. But that was, I haven't seen any data or papers talking about it. If it's any different. But that's a good segue to long COVID news. So we're talking about there's some papers mainly. I mean, there hasn't been any, unfortunately, breakthroughs with long COVID in the past 2 weeks. Is unfortunate, but there has been some papers that have popped up last month that I missed, and one that popped up recently from someone in our group. But this one talks about they did a pretty nice job at using this. This is the methods. They basically use a machine learning method to identify infection subphenotypes. So this is just the figure one from the paper, but they have a couple of nice figures in this paper where they had the long COVID topics they categorized within these 10 different groups within the machine learning group, and then they talked about the probability of someone getting that, but if you fall into some of these groups and how often it occurs. So they've had the disease in the blood, different muscular, nervous systems, neurological, and so on and so on. So they did it, and then they have another figure in here where they subcategorize each of these, saying the probabilities from, let's say, cardiovascular subtypes, what are prominent and stuff. But this is a nice informative paper. We're using the machine learning tools and looking at health records, electronic health records over the past, whatever is available to actually categorize and figure out what's more prominent and probability of getting it. Again, I skimmed over this paper, and I thought it was a pretty nice paper where they categorize things nicely and giving you sort of even more robust percentages of what's happening. This paper just came out 2 days ago on January 1st, on New Year's. So this is from Justin Reese and Peter Robinson, as some of you guys know them, and Hannah's here. So Hannah, you're here. I think maybe you could talk about this paper more than me. I don't know if you want to give a really brief synopsis.
Can you hear me?
Yeah, we can hear you.
Okay.
Sorry to put you on the spot.
No problem. This also is a paper that clusters long COVID patients gleaning information from their electronic health records. And it's part, as the title indicates, it's in the context of the N3C National COVID Cohort Collaborative, I think is the last word,
Yeah.
database. The data extraction is centered on a list of phenotypes that are associated with long COVID that Peter Robinson curated. Initially, it was curated from the literature. This was now probably a year ago that he came up with a list of phenotypes, and these are coded in terms of the human phenotype ontology. So the clustering in this paper relies on the human phenotype ontology as the language in which patient symptoms are expressed, and then applying a method which I'm sorry, I can't remember whether Peter ever talked about this here, but it's called semantic similarity, meaning it's a similarity measure that's based on the structure of the ontology, so that terms, the point is that you want to be able to relate phenotype terms that are not identical, but they may be closely related in the ontology. And so you have a similarity measure based on information content that allows you to compare patients when their symptoms are related but not identical. So using that as the basis of the similarity measure, the clustering algorithm is simply a k-means clustering, so nothing super fancy in terms of the clustering algorithm itself. As usual, one has the difficulty of deciding how many clusters, like what's the magic N. I think, I'm trying to remember, I think in this paper, the magic N is 6. So there were 6 clusters identified. And as you can see on the right here, some of them, I mean, whenever you do a cluster, the hard question is, how do you characterize your clusters, right? I mean, you can always get clusters. That's not the problem. The problem is figuring out whether they're meaningful. Right. So this figure is trying to characterize, some of the clusters are heavy in respiratory symptoms, some of them are heavy in pain symptoms, etc. So the labels for as you can see at the very top of the figure, we came up with labels for the clusters based on what we felt were their salient symptoms. And again, these symptoms are in terms of the human phenotype ontology. So each of those symptoms can be traced back to a set of terms in the ontology. So what else can I say about this? The bottom figure, I'm trying to recognize that.
I think this was here to complement what was your color code that you guys put in here, right, for the different settings.
Oh, I guess it's, yeah, I apologize. I didn't make this figure, but I'm thinking it's the percentage of patients who have, like if you look at cluster 1, it looks like 100% of the patients who fall into cluster 1 had some HPO term that was related to laboratory results. Right. So that's how I would read this this chart, which is, so cluster 2, for example, 100% of patients had a pulmonary symptom, and that's why that cluster is labeled pulmonary. Right? But again, I mean, I'm pretty, what shall I say? I'm very excited about clustering, but I'm also a little bit, I'm skeptical in the sense that you have to remember that any label you put on a cluster is, when you label your clusters, you are making an assertion about the statistical distribution of symptoms, right?
Mm-hmm.
And you know, okay, so how do you support that? So in other words, you're making this kind of hidden assertion, and then people don't always successfully justify their labels. I mean, I think in this case we have, because the red highlighting in figure B is the explanation of how clusters got their labels.
Right.
But it's just, I think it's good to bear in mind when you're doing clustering how much of the beauty is in the eye of the beholder in terms of cluster interpretation. That's all. But
Yeah.
anyhow, I don't want to take up more time. That's the essence of the paper.
No, thanks, Hannah. I put you on the spot, but that was great. Give you a short synopsis. Maybe we'll see if you and Justin and Peter might want to give a longer preview of this and some of the ongoing work in the future meetings.
Well, I think the hardest part is going to be, you know, pinning down the date. But Justin and Peter have presented this paper in various stages of completion several times already. So
yeah.
I don't think doing another presentation would be difficult for them.
That's true. Yeah,
it's just a question of scheduling it.
Right. Well, no, thanks. Yeah, I put you on the spot, but thanks. That was great. I think yeah, go ahead.
No problem.
Is this available as an sort of online? I see e-biomedicine. Is it something we could look at?
It's open access, yes. So you should be able to find it.
Yeah, the link's here. I could put it in the, or I don't know if someone else might throw a link in the chat while we're going through this. But yeah. Yeah, no, it's open access, as Hannah said, yeah, which is great. Because I don't think through my institution, I wouldn't have been able to get this if it wasn't open access. Any other questions? Since we got Hannah here, we could pick her brain too. Not.
I was just going to say, I'll dig up the link as soon as we stop. As soon as
okay.
we stop
It's right here. I'll share. Yeah, I'll share these slides also with people afterward, like I usually do. But the link's here. Don't want to wait till I share the slides later. You can just put it in the chat.
Yeah, I just want to warn you: don't read any of the older versions on the bioarchive, right? Because the paper has evolved in response to reviewer comments. So you really want to go to eBiomedicine to get the true published version.
Yeah. Thanks. Okay. Yeah. So this is this is another paper that came out on long COVID just this past December 21st, right before the break, which is really interesting. I thought I didn't see it until today, but this is just a figure one of the paper, but there's a lot more they went into. But the whole, the basic overall synopsis of this paper, from what my brief skim of it, is that they're talking about persistent, smell or the loss of smell over time for long COVID folks. And they have been finding from this paper is that it's potentially related to persistent T-cell mediated inflammatory factors happening in the olfactory epithelium. And this is one of the biggest figure one, which I thought was a nice figure, pinpointing, different factors from their imaging and their sequencing, from their single cell sequencing that they've done do that. So I guess for folks like Eve, Jeff, they're mining. Might be some newer data that we could probably potentially tackle. That should be available somewhere online now. So take a look at this paper. The link's up here. Just share this link too. I don't know if anyone has any questions on this. I didn't read this in depth, but just a brief view of it shows some interesting things. They only looked at the olfactory epithelium, of course. So it's one tissue type, and doing the single cell, looking at different immune cells related to that tissue type, in the epithelium of the olfactory. But this was giving you some insight potentially why some people might have loss of smell as opposed to others, and why what could be targeting that for long COVID folks. Okay, so that's sorry.
Did that study use animal models? I seem to recall reading it, but I don't remember the specifics. Is that just human patients, or did they use animal models as well?
I have to go back. I skimmed it. I think it was just patients, but okay. I got to go back and look. So don't quote me on that.
Yeah.
if someone has read this paper and knows answer to Kevin's question, let us know now. If not, well, yeah. So we'll go back and look. Yeah, but I think you're right, Kevin. So then, that's the science part and what I've seen from new papers. I'm sure I'm missing a bunch of other papers that have come out that might be interesting. So people have some, please share. This is just a past long COVID dashboard, which I showed this because there's not any other kind of dashboard out there. So now going into how the spread and what's occurring. This is from this guy Raj dashboard, which I like. He's showing the variant spread as expected, and what I mentioned earlier, the XBB.1.5. You can see where it's more prominent in the states that are in the Northeast. BQ.1, of course, .1 is still around, but this is quickly taking over. Now, as expected in the wastewater, I'm sure Adam will tell us this too, is that you can see in BioBot the increases happening in the wastewater from the latest findings, which were January 2nd reported, which was 4 days ago. And you can see, again, as you would expect, dominantly it's the Northeast area where it's rising cases in the wastewater. And then this is kind of distribution. This is nationwide distribution. You can see XB, where is it? XBB, the dark purple is here. And the sublineages, if you read the asterisks, I think XBB.1.5 might be somewhere in here. But if you go to Northeast, you can see, of course, there's a lot more prevalence of it from the wastewater than nationwide. You can see, but if you'd have to just go here and click on these things and figure out where the variant distributions are with your region. And then I just show Middlesex, which is county in Massachusetts, where I'm at, and you can see the big rises you might expect from everything we've been hearing about, cases rising and hospitalizations rising. The wastewater is very well showing that there's a big rise happening and still going up. Probably more happening, I would imagine, from the holiday break and New Year's. I showed this earlier, just the COVID tracker, CDC COVID tracker in the U.S., the XBB.1.5 now in there. Okay, so then the global distributions. This is just kind of a mess here with all the countries, but just showing the overall pattern that their cases are rising depending on region. This might be easier to look at, just the more general, like the European region, Japan, South America region, United States, and showed some of the Asian countries here too. Showing Hong Kong, because we know in China the cases are very high and the hospitalizations are just skyrocketed there, but their reporting is not very reliable, unfortunately, from what we get. But people kind of look at Hong Kong since they do have reliable reporting, and it's the neighboring country, and they kind of make assumptions that way from what I've been reading. But you can see Hong Kong, how the number of new cases are in comparison to other regions. This hospitalization is not Hong Kong, it's the United States here. And then here's South Korea, I believe. But you can see the new deaths happening in Hong Kong has skyrocketed also. And I'm only showing here from April till now, not from the beginning of COVID pandemic. But yeah, so you can see that happening. That's concerning. A little lag between them. Okay, so now just going to individual countries and around Europe and the different distributions. You can see, for example, in Germany, since Europe doesn't, as Paco pointed out earlier, Portugal, Europe still doesn't have the XBB.1.5 very dominant in the European countries yet. Still BQ.1.1. So these are the residuals coming down from there. There's France also. You can see cases are going down again. Usually, in a year ago or year and a half ago, I would say usually U.S. will follow the trends of Europe. Something will happen in the UK, Europe first, and then happens to us. But I think since this XBB.1.5 is originated from is originating from the U.S., this probably might be reversed. I would make a speculation. UK, for some reason, hasn't had any cases go up, but you can see things have stopped reporting. And then I found this article, maybe it came out the day after Christmas, saying UK stopped publishing COVID R numbers, which is the kind of their estimates of how reporting for cases and things like that. So I wonder if that's why, you don't see cases going up because of they're just not doing any reporting that well anymore. I don't know if anyone has any insight who has UK relatives or know more information about that.
Well, I was over there over the holidays. This is Steve, and it seems like just anecdotally, there's a lot more COVID around than's being reported here, and masking is trivial. I mean, you can be dense pack anywhere you go. I mean, my wife and I masked everywhere, but we were often alone in that, whether it be the tube, the subway, a big department store, whatever. But I know we hear plenty of people who have gotten it and recently. So,
yeah, that's why these numbers, when you see the reporting, it doesn't make sense.
So, are you saying then that the title from this report, as cases fall, is perhaps a misconception? They stopped publishing their R number because they chose to ignore the rise in cases. Is that what you're saying?
I would imply that, yeah. I would say, yeah, exactly what you said, huh, Hannah?
And again, with the caveat, somewhat anecdotally, when we talk with a lot of people politically aware, they would substantially support that. It's just they've given up reporting, and so it's chaos, and there's plenty of COVID around.
Thank you.
Yeah. Yeah, so then when I look at these, or when other folks look at these case numbers, I'm not sure how valid, or how for at least the UK, what we should do for that, unfortunately. US, we already went over. You see hospitalizations are going up, cases are going up. South America, again, XBB.195, I don't think is not that prevalent yet there. Maybe, I don't know if Jordana, you know more about I think it's BQ.1.1 still in Brazil, right, Jordana? Sorry to put you on the spot. I don't know if you know.
Yes, still around, but at very lower percentages. I would say that we just had today the first case report on XBB, so it's probably circulating and taking over.
Okay, yeah, because that's what I've been hearing also. Okay, but the cases, good news is cases are going down for you guys, but I guess it might be a red herring or misleading things. If anything happens, followed US's trend. We'll see.
Yeah, I don't know if our cases are going down because people are not testing or just because it's really going down. So.
That's a good point.
Because people are just not testing during the holidays. They just don't want to know. That's what we see all around. So not good, though.
Yeah. I think that might be kind of a global phenomenon. So Japan, before, this is like, I think this is from last week or right before Christmas, it was peaking, but then now they're dropping again. So that might be good news. So same with their deaths. South Korea, they had the peak. Seems like they kind of plateaued for hospitalizations, but it's going down again. The dominant strains there, I think, are still BQ. But the issue is this article that you read about China that says we don't really know what variants are coming. There's some sequencing being reported now, but it's very low. So there's a hodgepodge of variants that are being reported coming out of China, but we don't know what's really being dominant variant and what new ones are popping up that should be hopefully reported.
Afshin, do you know anything about the amount of vaccination in China?
Well, if you look at one, let's say if you look at what's been reported, they say 90% of people are vaccinated. How accurate that is, I don't know.
But that was with the older vaccine, wasn't it? It was the original variants, and I don't know whether or not they've done a booster program.
Yeah, I don't know that either. Yeah, exactly, Rob. You're 100% right. Yeah, and the booster, no information on that either. So we don't know, as Rob said, we don't know what they're doing. Yeah, just unfortunate we don't get reports that way from the rest of the country.
And do we know how effective is the Chinese vaccination?
From back
I
originally,
think the details were very sketchy.
yeah. I think that someone was doing a study in South America on this, or maybe it was Brazil even. I don't remember the results, but I remember it wasn't as effective, obviously, as like Pfizer or Moderna vaccines, from what I remember. But again, my memory's sketchy on that. I don't know if anyone else remembers.
I was just going to
Well-
repeat. Go ahead.
Sorry, go ahead.
Well, I have no true knowledge. I was going to repeat what National Public Radio has reported, that what they reported was that if you have 3 doses of one of the Chinese vaccines, that provides protection, which is, I guess, comparable to the Pfizer or Moderna vaccines. In other words, you know, you have to have an extra dose maybe, but you can achieve a comparable level of protection. The problem is that from the report on the National Public Radio, most people in China have not had 3 doses. So even though they could have been protected, they haven't been.
Yeah.
And for various reasons choose not to. The problem is not so much that the vaccines are inadequate, but that the vaccination program is inadequate.
Mm-hmm.
Well, that's pretty much what I was going to say. And clinical trials on CoronaVac, which was produced by Sinovac, a Chinese company, the clinical trials in Chile, in Brazil, and they show that it's only 58% effective with the 2 doses, and it increases after a third, like a first boost and a second boost, which means 4 doses. But still, it's not very effective in the elderly population, so this may be a problem. Combining CoronaVac with other vaccines in a heterologous boost, for example, that would increase the efficacy of the vaccines. So, yeah.
Oh, thanks. Yeah, I think I remember that study you mentioned, Jordan. Yeah. So I guess the question for Doug's original question, we sort of covered it. And Waldemar's question too. Yeah.
Yeah, thanks. That was great help.
What I read also was interesting. In Hong Kong, there's more availability of the Western vaccines, but I have no idea whether that means anybody can get it. But they do have the Western vaccines in Hong Kong. How it impinges on those curves you saw, I mean, I have no idea.
Yeah, because going back to Hong Kong, they're not doing too well. So I wonder. Here's the green curve. Yeah, I wonder what's their percentages of vaccine. I have to look that up.
That's what would be interesting, because they said people can get the Western ones.
Yeah. Maybe I'll look that up for next week. See what's going on there. Because they're not doing too well compared to the rest of the countries right now. And then I guess where were we? South Korea, and then I said Australia was similar trend with the rest of the countries around that region. Or close to, I guess, sort of close to them. But, they're up, they're going down. Again, I don't think they don't have much of XBB from what I read. It's BQ .1.1. South Africa is another thing like UK, where for some reason now they have no cases, 0. But when you actually look at their tracker, they have this message here saying pandemic status on this page is no longer being updated. This is from July 15th. So this is where things went flat. So unfortunately, if anyone, I don't have any colleagues or anyone in covert from South Africa, but if anyone does and wants to bring them in and let us know more insight, that'd be wonderful. But they're actually really good at reporting before this July 15th, and they had a good sequencing surveillance program, and so what's happening there? So that's an unfortunate thing. So whether the cyclical pattern happens more, we don't know how many cases are happening, unfortunately not. But that's about it. I don't know if people have any comments, questions, topics they want to bring up. Okay. I guess then next week we'll resume, and if anyone wants to present anything in the coming up meetings, let me know. I know there's a few people we'll have present later in a few weeks, some of the data they have. But if people want to present, just let me know, and we'll schedule you in. Or if you have any suggestions for how people to present. But if not, we'll give you 10 minutes back of your time. And no, thanks everyone.
Thanks, Afshin.
Thanks.
Yes,
Thank
thank you,
you.
Afshin. Happy New Year.
Yeah, happy
Thanks,
New Year,
bye.
everyone.
Thank you, everyone. Happy New Year.
Happy New Year.